Aerospace engineers have looked to nature for inspiration ever since mankind first watched birds in flight. More recently, we're able to look for inspiration not only in the sky, but beneath the sea. Fluid moving around a fish body will behave very similarly to air moving around a body in the sky. I'm looking specifically at shark skin. Now, sharks have had 400 million years to evolve and adapt to their environment. And through this time, they've been able to develop several evolutionary assets. One of these assets takes the form of microscales across the shark's body. These scales work to bristle up and inhibit and reduce a flow phenomenon known as separation. But what is separation, and why do we care about that? Let's imagine a shark swimming through the ocean. As fluid passes over the shark's body, around the widest portion by the gills, that speed of the flow will increase. As it tapers off towards the tail, the speed will decrease. This creates a pressure difference, high at the back, low in the middle, that wants to force low momentum fluid along the skin of the shark, the wrong direction. This reversing flow leads to what's called a separation bubble. And it can lead to increased pressure drag, not only for sharks, but for any body that experiences this phenomenon. So how do shark scales combat this? Well, sharks have 200 micrometer scales that consist of a crown connected to a thin stem that anchors it into the skin. These scales all can passively bristle up to a maximum angle depending on where they're seated on the animal. The places with the highest bristling angles exist behind the gills, at the back of the tail, and at the back of the fins, the same places we would expect separation to occur. And indeed, we see separation control testing samples of skin from these places. But I can't see what the scales are actually doing in these places. So I've constructed a 3D printed model of 9,000 shark scales that all individually bristle in reversing flow. When they encounter this, they bristle up and the flow is forced into cavities between these scales and recirculates. As the scales are pushed back down, this fluid is injected back into the core backflow and mixes momentums. This momentum mixing reduces separation. Understanding this, we will be able to create some sort of surface that replicates shark skin that can actually help the performance of our sea and aircraft. Thank you.
Thank you, Andrew.